Okay, so we've now hopefully breadboarded the circuit for the LED flashlight or strobe light. And now we want to actually build this particular project. So the first thing we're going to need to do is create a printed circuit board that we can solder components onto and then make it part of the actual physical flashlight. We can't stick a breadboard very readily in a flash board. It's not going to be secured together very well, and it's not going to be made small enough to be practical. So what we're going to end up doing is we're going to be taking all these components here of our parts list for the flashlight, strobe light, and we're going to be putting together a circuit using copper on a copper printed circuit board. Our footprint is going to end up looking something like this here, which looks a little bit arbitrary, but these pads here are things that are what we're going to drill through, and then we're going to solder components into those, in between those pads. So for example, this 10 microfarad print here, there's going to be a 10 microfarad capacitor that's going to fit in between the negative and the positive pad there. Likewise, it's a little bit hard to see, but there's 4 pads here, 4 pads down here. That's going to be the footprint for your timer socket to fit into. So we got to create this. We're going to use something called computer aided design for this process. Now in the past, and for this example on here, they've used a program called Easy Route 2000, which was made back in the 2000. We're going to be trying something a little bit different, something a little more modern, and we're going to be using Fusion to create our electronic circuit board. Now, up until recently, I had no idea that Fusion was capable of doing this. I've used it for 3D modeling and stuff like that, but I've never actually used it for electronic circuits. So this is definitely a new concept. I've had to spend the day today trying to figure this out. And so let me guide you through it. So hopefully by now, we've all got Fusion on or access to Fusion on a computer, or using a school computer, whatever. But let's open it up and take a look at it. So again, I've used this particular software for 3D modeling a bunch, and it's really powerful and it's great for that. I modeled a bunch of things, and I'm happy to be able to use it as well for making circuits also, or trying to anyway. Anyway, here we go. So this brings you, once you open up Fusion, it brings you into the window here for creating a 3D model. That's kind of going to be its default. What we're going to do here is we're going to click on the drop down menu and create a new electronic design. So that's going to change the look here. And we are going to start by creating a project. Now you can see I've got a few projects here. If I go to my home, I've got a bunch of projects that I've worked on in the past as well. We're going to start a new one, and we'll call it, let's call it strobe light. So click enter. Okay, so now what I want to do here is on the tab I'm going to be using for the electronic design is up here. I want to save that. I'm going to save it to my project called strobe light. So here my location, strobe light, and I'm going to call this strobe light project. Okay, so now I've created my strobe light project. Every project, when it comes to creating a PCB, printed circuit board, is going to consist of a schematic diagram as well as your PCB. And we always start by creating a schematic. So basically the handout that has been given out to you of the schematic of the strobe light, you're going to be replicating that in this CAD program, and the CAD program is going to be taking that information of how the circuit and electron flows through the circuit, and then produce a series of component pads that'll be turned into the footprint of your PCB. So the first thing we want to do is replicate our schematic. So I'm going to click on new schematic here. That's going to open up another tab eventually, after it's thought about it a little bit. I'm going to just exit out of this panel for now. Okay, so this is where I'm going to create my schematic, in this window here. And over here I'm currently in my design manager. I'm going to toggle over to place components, and I'm going to begin to place all the components that I'm going to need for this circuit into that window. But before I do that, I need to ensure that I have the components available within the Fusion program. And so there's all sorts of different libraries, there's millions of different components that you could potentially use. They use this software for like commercial purposes, making like actual 16 layer circuit boards. We're not going to be using this program to that extent. We're using it at a very basic level, but we're going to need to ensure that we're utilizing the appropriate components for our project. So we're going to go to place components, and the first thing we're going to do, I already have these libraries incorporated, but you probably won't. So you're going to go to where it says all libraries here. I'm going to go to Open Library Manager. And here we got 886 different libraries full of different components in them. And we are going to search for one called Adafruit. Adafruit is like a crowdsourced community that particularly works with like electronic type projects and stuff like that. So you can see here that I've got this particular library already in use, just to ensure that it's toggled over and it's blue. I'm going to add one more library. We've got battery here, and you'll notice again the library is called battery. It's under a folder named Eagle PCB version 3, and you can see I've got it in use. Make sure you have it in use as well. Okay, so I'm done with my library manager, and the vast majority of components that we're going to be using are going to be found in Adafruit. The only exception is the battery, and for this project we're going to be using a 9-volt battery with our battery clip. And so I'm going to search battery here, and I'm going to go to my battery library, and I'm going to grab it's all in alphabetical order. I'm going to grab this AB9V battery, and 9V standing for 9 volt. If I come down here, I can see a description of what I'm adding to my design. So I got my schematic symbol here, my PCB footprint, which includes the pads that are going to be left to solder onto. And I recognize this is all kind of going to be arbitrary if you've never taken electronics before, but just kind of trust me on this. Hopefully it makes sense in a little bit. And okay, so that's what I want to use. And if I just click and hold with the left mouse button, drag it in, there is my schematic symbol. I'm going to drop it in place. I want to rotate it straight away. Oh, whoops. Let's exit out of there. I've already placed it, so now I gotta go up here and rotate it. If I click on it once, it'll rotate, and that's how I want my battery orientated. And if I use my mouse wheel, I can zoom in and out, like so. Alright, component number 2, I'm gonna grab my resistors, and now I'm gonna be using the Adafruit library for the remainder of my components. So I'll just put that one, click on that one there, and I'm gonna look for resistors. So I'll just type that into the search window, and for resistors I'm looking for a 0207/9. That's going to be found under RUS. So you have European resistors, all sorts of different types of resistors. I'm going to be looking for the 9 here. So I think I have it already on there, 207-9. Again, you can see the PCB footprint and the schematic symbol. I am going to drop one in up here somewhere and down here, and we can always move them around later. Alright, so I just got 2 resistors in this particular circuit. Next I'll grab my capacitor. So I'm going to be looking under C-pole US, and I'm going to be looking for this name here, E2. So you're gonna have to look for it. It comes up as a default for me just because it's the one I've already been using. It's gonna be this one here, E256. So I can drag that in as well. Oops. Let's try that again. E2. Okay, I don't know what was glitching there, but here is my capacitor symbol, and I am going to drop it in here. Actually, I'm going to rotate it and drop it in there. So I got my negative now of the capacitor. That curved line is facing the negative of the battery. Alright, so I'm done with the capacitor. Now let's move on to my LED. Oops. Alright, so let's type in, oh, we're done with that. So let's go LED. And again, you'll be clicking on the drop down and searching for the 5mm. So that's the one I want to use. And I'll drag that in there. And I want to rotate it, I think this way. No, this way. There we go. I'm going to place it kind of beside that resistor R1 up there. And I'm done with that. Now I want my, let's go with my potentiometer. So I'll type in pot up here, and I'm going to be looking for this one. That's the footprint I would like. And so this particular potentiometer we're using in the project is going to be a switch as well as kind of a variable resistor. So the switch portion of it I'm going to place up here, and I'll rotate it around. Oops. Just going to move it up a bit right there. I'm done with that. And then I also need the potentiometer part of it. So I got the switch and now the potentiometer bit. And so the schematic symbol is changed. I'm going to place that right there. Finally, we need the timer. 555 timer. So I'll drag that in. And there we are. And I'm just going to kind of place it right about there. But we can always move it around if we need to. Okay, so those are, I believe, all my components that I need. The next step is I'm going to connect them all together. And we do that by something called a net. The net feature is up here, and you can see it's under the tab Connect. So we're going to press on that net there and just start connecting my components up as is demonstrated in the handout that I gave you. Now, I don't have the handout in front of me as I'm working on this, so mine might look a little bit different, but just make sure yours is looking just like the handout and you should be in good shape. All right, so if you hover over the end of a component, it's going to create that circle, and once you click, it's going to create your line there. And anytime you click again and then move it over in a different direction, it's going to create a right angle. And you can see the right angle button has been pressed up there. I'm going to move this resistor up a wee bit. It's a little bit better. I'm going to do the same thing with this LED. So I can just kind of click and grab it as well. All right, I'm going to, off of that point, I'm going to connect up my resistor and then my LED. Just move that out of the way a little bit. Oh no, I got stuck over there. Oh, I can take it. Okay, that's okay. We'll leave it there. Off the LED goes to pin 3. And then I'm going to loop around off this point. So I can connect up to an existing net, and you can see there it's made that circle. That's just indicating that there is a true connection. This one's going to loop all the way around to my potentiometer. Okay. And now let's go back to the negative. The negative of the battery is going to go to the negative of the capacitor. And then from the capacitor, other side, it's going to go to... Ooh, I don't really like what I did there, so I'm just going to delete that. I'll press the delete button and that line, go back into net. It just didn't look very neat. And I'm going to connect the resistor to the potentiometer. The first side of the potentiometer can go back up to the slider of the potentiometer, like so. So that's what it ought to look like there. Now in between the resistor and the potentiometer, I'm also going to go to pin 7. Oh, and then from my positive over, where is it? From 4. So I'm going to create a junction point there to my 8. So my 4 and my 8 are connected. My 2 ends up going back to the other side of my capacitor. So I think I can just toggle off that point there. Okay, 6 goes back to 2. So I can actually connect it to there because it goes back up to 2. So you'll notice my timer here that everything is connected but the 5. That's by design. The CV pin 5 doesn't need to be connected to anything. All right, is everything else connected? I believe so. So now at this point here, I just want to tidy some things up. So I'm going to go to the move command, and I don't really want to do that. I can Control Z to fix any mistakes or what have you. Maybe I can, again, I'm learning this stuff. I want to move the whole line down a little bit just to kind of condense things. So looks like I can select both those components and bring it down. I think that's looking pretty decent. Now the next thing I want to do is I want to assign values to my resistors and the components that need those values. So I'm going to go to modify, and under modify I have value, and I guess I can click on the shortcut key V, and under resistor, this resistor here is going to be 1000 ohms, so I'm just going to put 1K up there. The LED, it's going to be a white LED, so I'll just put in a value there. The capacitor is going to be 10 micro farad. I have no idea where the mu is, so I'm just going to type in micro. And this resistor here is 2200 ohms. And the potentiometer is going to be a 100k ohm resistor. So I'll put that in, and I believe that's all I really need there. Okay, yeah, that should be good. So a couple more things before I'm done. I want to just sort of tidy up my lettering so it's a little bit easier to read. And I'm going to go do that by going to modify. I'm going to like rotate these around, and then I can move them into position so that someone could actually read it if they need to. Those ones are pretty good. That's not bad. I'll rotate this one and this here and move them. Whoops. Okay, I think that's looking not terrible. Lastly, I want to put my name on it. So I'm going to go to document and I'll go to the text tab. I'm going to write in the name of the project, so Strobe light. my name, and I want you all to do this as well, and then the date. We'll go February, in my case 8th, 2025, and I'll bump that up to 1/10 of an inch. I'm going to drop it in right there. Okay, so this is my schematic. That is now complete. I'm going to end the video here pretty quick, and I'll make another video on how to convert this into usable PCB once I figure this out. But first of all, let me just kind of give you a sneak peek if I can. Now notice here I have my schematic here isn't saved, so I should probably do that. So I'm going to call it strobe light schematic. Save it. And now, remember when we first started out, we had our project and we saved it as strobe light project. And you can kind of see these symbols here. We got a schematic symbol, and then behind it is a PCB. So if we press on that, it'll once again change our window. And here's our schematic. And let's go back into our schematic tab up there. And I'm going to go switch views into PCB. Okay, so here's my strobe light project, my strobe light schematic, and this I'm going to rename as my strobe light PCB. All right, so under my project here, I got my strobe light schematic, my strobe light PCB, both version 1. Here's my schematic, here's my PCB. Now if I go into the PCB here, I got all these different components here, and in green are going to be the footprints of the pads of the components. And I'm gonna end up bringing them over here onto this window here, and eventually arranging these around so that my nets and stuff like that don't overlap. It's going to take a little bit of work, and it's going to be, honestly, it's going to take a little bit of figuring out on my end. So we're going to end the video there, but the first step of the strobe light project and creating your PCB is to create this strobe light schematic. And so I want you to do it essentially how I've done it here. Follow the schematic that I handed out. That's going to make it a lot easier, but I do want you to title the strobe light, or title the schematic as I have, put your name, put the date, and then this will be part of your mark for this particular project. Okay, I hope that helps. Again, this is a little bit experimental. We're going to see how it goes. But yeah, we'll tackle any problems that come up together. Okay.